I'm Jessica Major. I'm a DevOps engineer, so a lot of deployment type stuff. And I want to talk to you about Docker today. So what's Docker, right? It allows you to package applications with its dependencies into standard unit for software development. So it's a container. And containers are not a new concept, but what Docker does differently than a lot of implementations is it gives you a layer where you can run shared bins and libs. So you don't have to deploy those 5 or 6 times on one machine when different applications are using them. So why do this? Why even use this? It forces you to split your components into their true component parts. So oftentimes, we write code and it gets tangled in with other code, and then you have to deploy the whole thing somewhere for it to work. Docker makes you pull the things out into a container that do a very specific thing, and then you can test that, deploy it everywhere. So it lets you upgrade those components independently of one another. And it simplifies testing, because you can actually test one component instead of testing your entire stack because you don't know what other things the components are calling. It also provides better isolation. So when you're running in a container, it's segregated from other things running on the system, so it can provide with better security. It helps with processes and keeping the process that you're running under control. And my favorite is no more package dependency hell. So if you've ever done deployment of stuff, in a production system, you can be running 2 very different versions of something somewhere for, reasons like some guy left 6 years ago and nobody knows how to upgrade that database and it'll break. And so your production system looks very different from development, right? Because you can't actually have those 2 things installed on one box. But with containers, you can. So you can package that all up into one container for your old database and another container for your new one, and you can test them in the same stack. And that brings your environments closer in sync, because you know that you're testing the same container in dev that you're deploying across all your environments. So this is basic Docker architecture. So you have your server layer, your OS, and then here what you would have with a regular deployment would be all your bins and libs that are shared between all the applications, and then the applications on top of that. So Docker lets you have those separate, but it also, the way that it builds the images, it lets you share those bins and libs between containers that use the same ones. So you're not just putting 5 of the same binary on a server and using up space that you don't need to use. So yeah, it lets you share those. So there's a lot of components to the Docker ecosystem, and it's very fast growing. So I'm just going to cover a few of them here. Engine is the main Docker thing. It's the supervisor process. It lets you pull and publish images, build images, containers, execute commands. It's what does most of the work in actually getting images and containers. Compose lets you put together multi-container systems. So if you have a system like an elk stack, right, that needs 3 parts to run, you can have a compose file that lets you specify all 3 of those, and you know that when you bring it up, you'll bring up the whole stack and it'll run. Registry lets you store and distribute images, and there's other options for this too. You don't have to use Docker Registry. You can, ECS is a new one, Amazon Container Service, right? You can use that. And I think you can just store in S3 and even in a file system. You can just push your containers and pull them from anywhere, but Docker does provide registry, which can be useful. And they also have a public hub where you can push your images if they are public. So Machine lets you deploy containers across nodes. So if you have a set of nodes and you're very specific about where you want what, you can use Machine to deploy that out. And Swarm kind of complements Machine. It'll let you combine those single hosts into a cluster that you can use. So you could use Machine to say, I don't really care where it runs. These are all my servers. Go build my stuff. So when most people say Docker, they're talking about engine. So that's what we're going to focus on most today, because it's the starting point in Docker. So the first thing you have to do is get a container, right? So the Docker pull command pulls images from the Docker hub. You can find really simple ones, like just a Debian base image, or you can find really complex ones like Thumbor, whose only job is to take a URL and serve you back a little thumbnail. That's all it does. But it's complicated, so it's layer upon layer of images being built. So when you pull down Debian, what you'll see is that these are the layers. So if you don't specify a tag, it'll always pull latest. But you can pin it tags, right? So similar to doing apt package management, you can pin to a certain tag, and then you're getting the same thing each time instead of just pulling the latest. So yeah, you have pulling the latest, and then that first hash is one of the layers, and then the next hash is the next layer. And then it's got the newest image for DB and latest. So yeah, they're built in layers, so more specific implementations generally have more layers. So like Nginx, right, pulls more than 2 hashes. It's pulling layer after layer after layer of the actual Nginx build. So yeah, Docker run is what lets you actually run the container, because you pull down the image, but then you just have this image of a thing on your machine. You can't do anything with it until you actually bring it up with run, and that's where you pass the configuration options. So there's a lot of Docker run options, but some of the main ones are you can run it and you can attach to standard in, standard out, or standard error. Detach mode runs it like a daemon, so you just kick it off and then it runs in the background. You can pass environment variables. Publish is important because then you can get access to the ports. So like if you're running Nginx in a container, obviously you want to access what Nginx is serving up. So that lets you access it on your local host. And volume, combine a volume on your host to a location in the container. So for example, this command here, docker run -p binds port 81 on your local host to port 80 on the container. Name lets you specify a name for the container. If you don't specify a name, Docker will just give it one, and it's kind of fun because it's got like an adjective and a name. So sometimes you get some fun ones if you don't care about the names of your containers. So the -v will bind my local directory home, petrolfire, docker time, Jake to user share nginx HTML in read-only mode. The -d will daemonize it, so I don't have to leave the terminal open. It will run in the background. And Nginx is the container on which that, or the image on which the container builds. So you can check on the state of your running container after you've launched it with a docker ps command. So here, let's see, you can get the container ID, the image, the command that's run, when it was created, how long it's been up, or if it's down, it'll tell you it's down. And you can see which ports are bound to, which ports on the Docker container are bound to which ports on your local host, so you can access them and the name. And you can also use Docker exec commands to pry open a container if you want to get in there and see what it's doing. So Docker exec -i-t is for interactive TTY, and you pass it the name and the command. You can pass it any command that you want to run, but if you pass bin bash, it's going to open a bash shell for you. It's a very simple bash shell, because most of these images, the idea of Docker is you build a very specific thing in, right? So these images don't have like Vim installed, because you don't need Vim to run an Nginx server, right? So when you get in here, like, they're all very simple, but if you have to get in, it's kind of neat because you can see what's in there and it can kind of help you like learn how they built it. So sometimes you want to build your own image, right? Because you don't want to have to like pass all those commands every time. You can speed your startup time by baking options in. Our example is a really simplistic one, but you might imagine if you're building like a lot of static content, you'd want to just bake that into a container potentially, or if it was variable content, you could mount a volume. But yeah, you can ensure consistency across the containers. So you can build the functionality you need in with a Docker file, and that's instead of passing some of the config on the command line. So even Nginx is just the container that we are looking at was built from a Docker file. So it just pulls from DB and Jesse, and it just runs all the commands that it needs to actually install Nginx. So that's why when we ran the pull of that image, you saw all those hashes, right? Is because this is going through and running these commands, and it's building layers on the DB and Jesse image. So use the Docker build command to build based on Docker files. So in this Docker file, we just did very simple from Nginx, copy our static files into that directory. And when you get these images on Docker Hub, a lot of them come with READMEs. So the reason we know that that's the location is if you go look at Docker Hub, which I can't get the internet, so we can't right now. But if you look at Docker Hub and you find the Nginx image that is the mainline one, you'll see in the README it says, to serve up files, put them in this location. So that's why you bind the volumes there. So yeah, when you run the build command, -t is for tagging it, and that'll give it the image name, basically. and you want to build it in the location that your Docker file is usually, depending on how your config is set up. So step 0 is it pulls Nginx, and then step 1 is it copies that, and you'll see the hashes for each of those layers that it's doing. And then it's got an idea of intermediate containers that it uses for building, so it gets rid of those, and then it gives you that hash of the one it built, which is the last step that it did. So Docker Compose can let you run multiple containers. So it would look something like this to put together a compose file, right? You'd specify the 2 builds. So the name of it, the build, the port, and then the container name. And you can pass a lot of options in here. This is a really simplistic version. So then publishing containers, like once you have your container, you probably want to be able to share it with people or deploy it on production or do something with it. So you can publish to a Docker registry. And it's just a really easy push command. So you can push to public or private. Public is the Docker hub, and I don't know, there's probably other ones out there, but private, you can set up your own private registries, and Docker push provides auth for different stuff, right? So like you can set up AWS ECS, and then you can have it source in your credentials. So you can be pushing your images into AWS, and then other people on your team can pull them down and run them and build them. So the benefit of all this is that in development, you can create those multi-home machines where you could basically run a very toned-down version of an entire stack on a machine and not have to deal with dependency issues, not have to deal with processes getting in each other's ways. Because you can have, in production sometimes, you run different services that use the same port, right? So if you set up your config properly, you can just bind those ports to different ports on the host machine and not have to worry about it and still be able to test it. So developers can test changes to single containers, and then you can set up that full stack without worrying about the conflicts. So for continuous integration, continuous delivery, there's a lot of registries and there's a lot of CI systems, so I won't cover any specific one, but most CI systems have hooks into things, right? So you could imagine that when you publish an image up, you could have your CI kick off a build and test if the image is passing like unit tests and then integration tests, and then if you actually have it kick off like a full stack, you could test that sort of test against it. And if you're really brave, you could trigger production deploys if it actually passes your testing, depending on how much you trust your testing. So yeah, in production, you can use the systems to explicitly, like in a data center, say, okay, I have this application and I want to deploy one container in this region and one in this region and one in this region. Or you can just say, like, I have all these servers and go find me the best stuff. And depending on the systems you're using, there's a lot of systems to do this, like Swarm and Machine Work, but Kubernetes is one that people use, and it's really good because if stuff goes down, it'll just bring it up. So you could not care so much about the region that it's in if you know that your services will come up quickly, and you could just deploy it wherever it can put it. So to bring it all together, the workflow allows the user to develop an image in dev, push it to CI, get feedback, and then have the same image deployed in production. And they know it's operating separately from other services, has its dependencies contained, and they can actually test it all the way through the stack. And that makes dev and ops happier. So why shouldn't you use it, right? Because there's always drawbacks. It can make patching security fixes more painful. You might imagine if you're building all those containers and they're building off of bins every time there's something in a library, like a vulnerability found, and you have containers that are based on that, you would have to rebuild it. So there's that. So it can increase the time to patch bugs, which nobody likes. Because it forces you to split the stuff. It forces you to do it, and that can be really painful if you have a lot of spaghetti code that's tangled together, right? So you could go down the path of saying, oh, I'll just do this one thing in Docker, and then 6 months later, you might still be trying to like pull that out. But in the end, it might be better for your code, because you don't want your code to look like that anyway. And it's, you know, a bit of a black box when compared to how you're used to doing stuff. So once you get used to using it, it's good. But in the beginning, it can be kind of hard to see how to get in there. All right, so I'm going to try to do a demo. It's not mirroring, so I have to look behind me while I do this. So sorry, guys. All right, so the first thing we want to do is list out our images. Move that a little bigger. All right, so these are all the images I have. So I have some Elasticsearch stuff that I use. I have the Docker Compose image, which lets you run Docker Compose, Ubuntu, Nginx, and Debian. And as we know, Nginx is just built on top of Debian Jessie, so if we inspected that, we'd probably see that that hash is somewhere in there. So I have Nginx because I didn't know about the internet, but I can show you. Oh, sorry. Yeah, so there's no internet. But it would look like the screenshot I had in the slide. It would go through, and it actually pulls each hash, and it'll show you a progress bar for each one. And then when it's done, it'll apply those in order, and you'll have a container. So, all right, so let's see. So let's run a container, right? So let's run, this is, I think, exactly what I had in my slide. So binding port 81 on my local host to port 80. We're gonna just set the name to, I like to follow their silly naming convention because it's kind of cool. And we're gonna bind home, my user, Docker time, Jake, static files onto user. Oh, and this doesn't tab complete, right? Because it's on the box. So Nginx, HTML. And we know that because of the README that I can't pull up that's on the Docker Hub. It says, to expose your files, bind it here. So I think that's right. You might get to see me destroy a container too if it doesn't go well. And then -D to run it in the background, and then Nginx. And that's the big hash it gives us that says this is your container hash. So now if we run Docker PS, we see our container running. So there it is. It's been up 8 seconds. So let's see if I bound that to the right place. So now if we curl down localhost, we get, oh, it's squished. It's a picture of Jake, though. There you go. Yeah. So we built a container. And it was really easy. And obviously, this is nothing you would use in production, but it's a starting point. So now let's try something a little different. So if we go into Docker time, I also have Fin. So here we're going to actually build from a Docker file. So all this does is it grabs the Nginx container and it copies static files in this directory into that share directory. So we'll do sudo docker run. Sorry, we're not running, we're building it. So build, T is to tag it, and then that just says use the Docker file that's in this directory. Oh, get my tense right, try that again. All right, so from Nginx, it copied that file in, and there's our container hash. So now if we do sudo docker images, we will see we have an image called Fin that we built, created 9 seconds ago. So that's how you build an image. So now we can run that same image. So docker run, so still have to pass the port, bind it to 82 because 81's in use, and we should still give it a name, so oops. We don't need to bind the volume anymore because we baked that in. We do need to still daemonize it. And this time we pass Fin instead of Nginx because we want to use the Fin image. So that's up now. So if we do Docker PS, there's our 2 images. And now if we curl down, 82, there's Fin. So there you go, that's my demo. Can't do much else without the internet right now. But yeah, do you guys have any questions? Oh, wait, let me go back to my slide deck. Because I have, yeah, there you go. So the slides are online. I made a little simple repo that basically has those ASCII art files in them and like the Docker file. It's really simple, but if you want to just play with it and have like 10 minutes, like it doesn't take very long. Just have to get Docker installed first. And then I referenced all the, ASCII art maker and stuff down here. So Yep, that's it.
Did you guys have questions, or did I just skip over that part? No?
I had one.
Okay, let me bring the microphone down to you, because we're actually recording our questions, too. If I don't, sorry if I do this loud.
Thanks. Hi, that was a good presentation. The problem is, I'm working in sort of an edge case environment running Docker on different platforms. Smaller devices like Raspberry Pi or Chromebooks or who knows what. And I'm finding that what you're saying is true if you have an ideal environment. Sometimes when you're trying to invoke Docker on another platform, whether it's a 32-bit platform or whether the kernel is different, you run into all kinds of nuances. Have you run into any of this, and do you know of any ways of streamlining it so that your containers really do work across platforms?
Yeah, I haven't so much. Well, a little bit, but I don't know if that's a problem unique to Docker, right? Because even when you just are managing like packages, right, you're going to be installing different packages if you have a different kernel version potentially, or you're going to have a different lib on that. You're going to have a different thing that your package depends on based on the kernel version that hasn't been updated or based on having a slightly different OS. So I don't know if Docker helps that necessarily. And given that, you have to spend the time investing in like building the stuff, I can see how it would make it a little more painful in the short term. Yeah, I don't know. I don't know if I'd have to think about that a bit, the ways in which that could help. I guess, if you use some of the like orchestration and configuration tools, you could maybe pin down specific things to go to different places. But you'd have to have multiple stacks to test, and yeah, I don't really know. I don't know if Docker helps you with that.
Okay, I'm on. All right, thank you, Jess.